We call a function that has a derivative at a given point or not differentiability. And it's nice to know whether a function is differentiable at a point or not. And let's look at an example of a function that's a little bit messy. So we said that the derivative of a function is the slope of that function at a point. So if I have a function like this one, and I want the slope at exactly that point, I know that that slope exists, and it's the tangent line to that point. It's the slope of the tangent line to that point. But what if we had a function like this one? What if we had f of x equals the absolute value of x? And let's say we wanted to look at a equals 0. Well, we know that the derivative at 0 of this function is the limit as x goes to 0 of f of x minus f of 0 over x minus 0. That's our derivative equation. And this, in this case, is equal to the absolute value of x minus the absolute value of 0 over x minus 0, which is equal to the limit as x goes to 0 of the absolute value of x over x. And the question becomes, does this limit exist? Does the derivative exist here? Is there a value I can get from this? And let's take a look. Let's look at the limit as x approaches 0 from the negative side of the absolute value of x over x. Well, if I plug in some points, if I plug in, we're from the negative side, so like negative 2 over 2, or negative 0.1 over 0.1, negative 0.01 over 0.01. And what happens is, if I plug in a point, I get something like this, negative 0.01 over negative 0.01. On the top, we lose the negative sign because of the absolute values, and so we end up with negative 1 as our answer. 0.01, 0.001, whatever happens, we get the same number over the same number, but since we're to the left of 0, we get a negative sign. We get the same thing. We get like 0.1, 0.01, 0.001, except in this case, both the top and bottom are going to be positive, so we're going to always have 1 as our value. So we see that the left-hand limit and the right-hand limit don't match up, so the limit as x approaches 0 of the absolute value of x over x does not exist. And the question becomes, well, why doesn't it exist? Well, if we graph this, if we graph our y equals the absolute value of x, what we get is when x equals 1, y equals 1. When x equals 2, y equals 2. When x equals 3, y equals 3. To the right of 0, we just get a straight line. To the left of 0, when x equals negative 1, we're going to have the absolute value of negative 1, so we get positive 1. When x equals negative 2, negative 2, negative 1, y equals 2. And so we get something that looks like this. And so what's interesting about something that's this shape, let's take the axes away. When we have something that's this shape, I can draw a tangent line like this. But I can also draw a tangent line, a line that only touches at one point, if I'm good at drawing, a line that only touches at one point like this. I can also draw a tangent line like this. No matter how many tangent lines I draw, there are infinitely many lines that could be tangent to a cusp, to a point, to a corner, for example. And so we have the derivative doesn't exist here. We can't define the slope at this point. And there are a few things like this. So let's look at non-existent derivatives. If the graph contains any of these things, if the graph contains these things, then, if the graph contains these things at A, then f prime of A does not exist. And the things we're talking about are cusps or corners. Something that looks a little bit like this. Right at this corner, the derivative will not exist. I should do this in a way that it's a function. Right at this corner, the derivative does not exist. discontinuities. We already saw that. The limits definitely don't exist in the case of like a jump discontinuity where the limits aren't going to match up. And then a vertical tangent line. A vertical line definitely is not differentiable. And you can think of that as kind of, we have slopes, right? We have the slope is heuristically telling you how steep something is. Well, a vertical line is infinitely steep. And so the limit doesn't exist. There's no number value that we can assign to that.